Hi everyone, so today we're going to be talking about the graphs of the quadratic function in intercept form. And actually, if Coach Fred had her way, we wouldn't call it intercept form, we would actually call it X-Intercept form. Because this is where we can actually see the X-Intercepts really just by looking at the function. So I want to look at the function in Desmos real quick because we have spent some time talking about this. So I put a function in intercept form. You can see it's actually really looks like factored form. So I also call it factored form. And if we look, we can see that the x-intercepts are 2 and 4. And what we discussed is that the relationship between the x-coordinate of the vertex and those 2 points is that it's got to be right in the middle, which means the average of the 2 x-intercepts. So that's an important concept if you see a quadratic function in intercept form. Okay, so let's go back to it. So again, we call it x-intercept form. I'm going to also, let's write next to it, let's call it factored form because it looks like the function's been factored, and in essence it has. It's still going to have an a. And when we talk about the variables p and q, those are the x-intercepts. Okay, so just make sure we see that. So how do we find the vertex? Well, in intercept form, we take the average of the x-intercepts. So for x, we're going to do p plus q divided by 2, because that's how you find the average. All right, and then to find y, we do the exact same thing we always do. You plug in x and solve for y. Our axis of symmetry is still that vertical line, so it's going to be an equation in the form x equals, and remember it's going to be that p plus q over 2. It's going to be whatever the x-coordinate of the vertex is. Okay, so now we're going to continue with our work on this. How do we find the y-intercept? We set x equal to 0 and solve for y. Symmetry point, we're going to reflect that point over the vertex. So we're going to use the reflection line. So we're going to reflect over axis of symmetry. Okay. How does it open up or down? We still look at a. So if a is greater than 0, it's going to open up. And if a is less than 0, it's going to open down. The x-intercepts, awesome. They're looking right at us in the face. So p comma 0 and q comma 0. Why am I writing them as coordinate points? Because they are coordinate points. My domain and range, again, remember the domain will continue to be all real numbers because I'm not restricted with anything I'm allowed to plug into the function. But the range, whatever comes out, is going to have to do with the y coordinate of the vertex. So look at y coordinate of vertex and whether it opens up or down, right? Because if it opens up, it's going to be from that point to infinity, and if it opens down, it's going to be from negative infinity to that point. All right, well, let's look at an example. So here we've got a nice quadratic function in intercept form, in factored form. I'm going to write down my x-intercepts first. I tend to do that so that we've got negative 2 comma 0 and 4 comma 0. Noticing that they are the opposite signs. Okay, so now I've got to find my vertex, so I have to average those. And let me just write them here for myself, just so I can see that. So to find x, we're going to do negative 2 plus 4 divided by 2. Averaging means add them together, divide by 2. So that's going to give me 2 over 2, which is 1. Okay, for y, I'm going to plug that right in. So negative 1 plus 2 is 3. 1 minus 4 is negative 3. So I've got negative 3 times negative 3, which gives me 9. So my vertex is 1, 9. That tells me that my axis of symmetry would have to be x equals 1. All right, switching gears, y-intercept. Remember, we set x equal to 0, solve for y. So we're going to get negative 2 times negative 4, which is going to give me 8. So 0 comma 8 is going to be my axis, my y-intercept. Okay, now, if I know I'm reflecting them over that line x equals 1 and I have 0, 8, then that means I'm going to have 2, 8 as my symmetry point. But if you have to graph it first, that's okay. Does it open up or down? It opens down because my A term is negative. Wider or narrower than the parent function? It's actually the same because the absolute value of A is 1. So it's not really changing its graph there. All right, so let's get that 1, 9 open. So 1, 9 would be here. 0, 8, 2, 8. You can see a beautiful, nice parabola. And we've got -2, and then 1, 2, 3, 4. So I can draw my parabola. Sorry, mine's a little off. Okay, my domain again, -infinity to infinity. And then the range, here's where we're looking at it. It's opening down, so we're looking from the bottom to the top. So we're going to be from -infinity to, what is that, 9, hard bracket. Okay, all right, so that's how you graph a quadratic function in intercept form. Hopefully that was helpful. Have a great day.